Hi. So, as Hugh mentioned, the title of my talk is Three-Shot Consultation with SetFit, which is kind of quite a nice idea for how to simplify your prediction workflows. So, a little bit about me. So, I'm a senior data scientist at the StepStone Group, and what we do is that we run different job boards around Europe and America, and like you might have heard of Total Jobs in the UK. So my team works on semantic search, document parsing, and for me personally, I also do a variety of what I call ML engineering stuff, which is kind of like deploying models, helping my team with cloud issues, that sort of thing. And kind of like there's my LinkedIn if you want to connect. Yeah, so for my talk today, kind of like a brief outline. So first, I'll kind of introduce you to kind of why we are doing this, what is SetFit and Sentence Transformer. And also kind of the last bit is a fun experiment I did to extend the capabilities of SetFit beyond text to like images. So kind of like the problem statement is like, how do we have efficient models for real-time semantic search? So for example, if you go land on Total Jobs and you are searching for kind of like a job position, you might say data scientist in London. So this sort of thing is quite easy. It's kind of like almost like keyword search. But what about if you say, I want to work outdoors, preferably for someone rich, then then kind of like a keyword search might not give you the most relevant thing in the world. So so kind of what our team is charged of building is that it has to understand these sort of like non-keyword type queries. But at the same time, because the search, it also have to be very quick and the results must be returned within 500 milliseconds. It has to be reasonably cheap to run because the volumes of searches that we do, and also which means that like first we have to host our own models, because otherwise if we use something like OpenAI, we will kind of be bleeding money. And the second is that GPU, even with your own models, can be expensive, so you will have to use cheaper GPUs. Yes, and then kind of, so once we got past these basic requirements, the two extra things that product asks us after they have seen the first version is that it has to understand the concept of seniority very well. So if you say a data scientist with 10 years of experience, then it should return you senior positions rather than like some sort of junior roles. And then the other thing is that for people who do searches with a location only, we want to be able to kind of classify listings into those that are skilled jobs that you kind of need some training before you can apply for them, and also unskilled that anyone can do. Yeah, so kind of like in terms of like the solution for requirements 1 to 3, it can be solved fairly easily with embeddings based on an encoder type model such as BERT or something from the Roberta family. These tend to be a lot smaller, and they kind of can be run quite fast on like even older GPUs. And we can also pre-embed listings and store the factors in a factor database. So that kind of, which means that when someone do a search, we only need to embed their search term and then do a very efficient factor database search. And then we also have quite an efficient surfing framework called Infinity, and with extra Onyx model compilation, we kind of managed to kind of get the inference times that down to 100 milliseconds for the kind of like core embedding model for the search. The problem comes with like requirement 4 and 5. So in terms of like the seniority, we have kind of like we have 7 different levels in terms of how we classify listings, and to get the labels for queries, we kind of, so it's kind of like a bit of harder to get to the labels, because we can manually label it, but it's also very time consuming. So we don't have that big of a training data set, and certainly not enough to do something like fine-tune BERT to do it. And in terms of like the skilled and unskilled label, we have in-house Mistral 7B model, which we use it for like parsing for different projects. So that model can return structured JSON file listings, and kind of like a skilled and unskilled is an extra field that it can return. But we can't do that without retraining the model, or we kind of like deploying a duplicate version of that with the extra field. So the second option is quite expensive. And the first option is that like when you retrain the model, you also affect all the other projects that are already using the existing model, which might not be desirable, because you can't really rely on the output until you have tracked it, which is not no, kind of like, so they're basically saying, no, you can't use it. You can't do that. So this is where kind of like this idea of SetFit comes in. But before going on to what SetFit is, I'll just kind of give you a brief summary of what sentence transformer is, in case you don't know about it. So a sentence transformer is kind of like a paper that came out probably like 5-6 years ago now. And if you go to the documentation, they basically say that it's kind of for training state of the art, like text and image embedding models, and it can, and so the idea of sentence, so kind of like most of the sentence transformer models are these encoder type models, and there's two main types of sentence transformer. So the top is what people tend to use for say, for example, calculating factors for factor database, and the bottom one is for re-ranking. So a bit more detail, but so in kind of like this version, you kind of, so you can think of this as like the query, and this is the document, the listings. And what you do when you're training is that for the listings that match your queries in your training set, you want to have them to have a high cosine similarity score, and for those that are not that are different, then you want to kind of like, as you're training, you want it to give out a low cosine similarity score. And once you have trained your model, then you only need like one part of this for calculating your embedding. So you pre-embed using one stack, and then you store that for listings, and you store that in the factor database, and then like this, the users go in here and you embed, and then you calculate the similarity score. So that's quite efficient. And then for this bottom setup, so you kind of like both of these have to go through the network at the same time. So if you think of, so you kind of like, so this means that you can't pre-embed anything, and you kind of need to put both the user query and the listing into it at the same time. And it will give you a score about like how well they match. And what you can do is that what you use the top thing to retrieve a larger set of results very quickly, and then you rank these results using this. So because like this setup, because there's so much more interaction between the two entries, it tends to be more accurate. And so kind of, but it also, because it's so much more expensive to compute, then you don't want to run hundreds of documents through it, because it'll take forever to return. Yeah, so how do we use that concept to build a classifier with few, well, kind of like not a very big training set? So this is kind of where SetFit comes in, and it's quite a nice idea. So first you use sentence transformer to generate pairs of sentences. You can train it and then you encode it. So because when you think of a classification task, you want to say whether kind of like there's for a certain say for example, like a senior or not senior, um, if I simplify it as a binary use case. And but even if you don't have very many labels um, per class, what you can do is you can generate a lot of permutations of pairs of your label data. So like a positive with a positive, a positive with negative, etc. You can train, and the idea with SetFit is that you train your model to classify whether the pairs are of the same class, of kind of like of same class or not. So which means that you kind of very easily bumped up your training data set. And so and in terms of like how we get from your text labels into your classification is that we know that we have these embedding models and we want them to be able to separate the classes. So this is where the sentence transformer fine-tuning part comes in. So as you so kind of you pass it these contrastive pairs and you generate the embeddings and you tune the embeddings according to kind of your contrastive loss, so that they nicely separate the two classes. And finally, once you have trained the embedding space, you put a classification head on top. So it can be something quite simple as a logistic regression classifier from sklearn, and it can actually give you a fairly decent result. And in terms of how you actually use the library itself, it's very easy if you know transformers from Hugging Face. It's more or less works the same way. So you kind of load a model from sentence transformers. So kind of like rather than model from pre-trained, just say SetFit model from pre-trained. You have a sort of similar setup with like training arguments. The only caveat being that because like the classification head can be a discrete one, like a logistic regression, but it can also be a multi-layer perceptron or a kind of like a differentiable head. So this is where if you pass in a tuple, then it will kind of let you set a different setting for the classification head if it's a multi-layer perceptron. And then again, you might have kind of be familiar with like the usual like trainer setup from Hugging Face, and then you can like trainer.train and let it run. For my use case, I can basically like finish get a decent result with a A10 GPU in like 30 minutes, something like that. So which is quite nice. And there's kind of like some observations that I found when I was using the library, and kind of for a lot of models, especially LLMs, if you have more data and like longer training runs, they tend to improve. But what I found is that because this technique is quite sample efficient, even running longer, it doesn't really improve metrics by a lot. So you can see that, like for example, I kind of like tried two different models here, and I tried different number of steps, and you can see that the score goes up a bit, but not by a huge amount. So depending on like what you're looking for, it might not be worth training for a very long time. And then when you want to kind of not overfit, so you tend to use early stopping. But an interesting thing to remember about SetFit is that because it's a two-step process, you actually fine-tune the sentence embedding first, and the early stopping only work on that. So if you want to kind of early stop, but only if the whole system works better, then you kind of need to customize your own training loop. And then also with LMs, you also kind of like, again, you sort of normally assume the more powerful model will give you a lot better results. And it sort of does, but not by as much as you would think. So the first model is like 10 times the number of parameters as the bottom one. And again, the scores are quite similar. So it's kind of like you might, so kind of in this sort of setting, you might want to kind of have a bit of a rethink of your assumptions. And I think I was kind of, this was also quite useful because a smaller model tend to be faster and also easier on your infrastructure. Yeah, and then kind of like you can also have observe like what's going on when you train the model using this sort of contrastive setting. So this is kind of a set of plots I did when I was training the skilled versus unskilled model. You can see that in the beginning of the training, there are two classes. So this is a t plot of the embedding space. So it kind of shrinks down the factors into like 2D. So in the beginning, you can see that the factor space, the two classes are very mixed together. But by the end, you kind of have this nice separation. So this is kind of which makes it easy for the logistic regression head or whatever classification type model you want to use to kind of distinguish the two classes. Yeah, and then I'll kind of so then kind of like I was thinking about my it kind of like on the weekend, and I was kind of thinking, well, we have beside text embedding models, we also have all these nice vision embedding models. So does this technique work with images? Because it seems like with factors, surely it doesn't really matter. And I kind of it so at the first pass, so I just shoved some images into it, but it actually didn't work. It kind of crashed. But after a little bit of debugging, I found that like in the current version of the library, the only thing that stops you from using images is that they have a default model card callback in the callbacks, which kind of relies on certain methods that assumes your input is text, so stuff like word count and length, which you can't do with an image. So because it's not for work, so I just more or less just hack the callback, and I just copy that, then remove the model card callback. And it actually did run. So I kind of picked a random image data set from Hugging Face. So this is like the beans data set, and apparently you're supposed to classify the leaves into 3 different classes according to which DCs they have. And I only kind of picked 10 examples per class, and I used all the default parameters. And I was quite surprised at like the nice scores I got. I was kind of like, right. Sort of like, I think, so kind of like this intrinsic experiment. I think so kind of like I shared the collab where I ran it. It does vary a bit. Like, I think I didn't quite manage to set all the seeds in there. So I've kind of, sometimes if I rerun it, it kind of don't give me as nice scores, but it did happen at least once. But yeah, so that's kind of something fun you can also do with it. Yeah, so kind of like, yeah, that's it for my talk, but I've kind of left 2 references where kind of like there's an original paper of on arXiv, and also they have a very nice repo and also a very detailed blog about how it works.